Hello students. So our next gas in the air is nitrogen, one of the key element. Nitrogen, it's a molecule of element, the formula with the formula N2, and it makes up around 78% in the air. So nitrogen gas, one of the key element in the atmosphere and for the plant life also. It is important even for us also, for the human beings also. How it is, that we'll discuss in this video. So first of all students, Nitrogen was discovered by the Daniel Rutherford in 1772. He noticed that when carbon dioxide and oxygen were removed from the air that remained was inactive. So what does he feel is that when oxygen and CO2 was removed, the remaining part of the air, he thought it is completely inactive, lifeless. The meaning of inactive is, and the animals died in this gas. Lavoisier named this gas as azote gas, or meaning lifeless. Later, Chaptal in 1823 named the gas as nitrogen. Nitrogen means that niter, N-I-T-R, coming from niter. Niter means potassium nitrate, sodium nitrate, one of the famous salt which is used as a fertilizer and explosive. So that salt generated, so nitrogen, N2. Sir, no, these are the early thoughts about nitrogen, but is it completely lifeless means? Right, the bacterial growth, all these things were not expected to grow under only nitrogen conditions. It is expected to grow under the normal air, which is in the presence of oxygen. But nitrogen is equally important for the plant life also, students. Why? Because all the proteins which all the plants prepare contains the key element nitrogen. So right. So occurrence of nitrogen, that means where this nitrogen is available. So nitrogen is available in the largest components of air, constituting around 78% of the air is nitrogen only. Nitrogen means what? N or N2? N2, nitrogen gas. So by volume of air, in the earth crust it is present as nitrate such as niter, like I have said, potassium nitrate KNO3, and chili saltpeter which is sodium nitrate NaNO3. Proteins are nitrogenous compounds that are present in all the living things. Like I said, all the proteins contains the key element. Of course, carbon is there, hydrogen, oxygen also there. But the key element which makes up that particular character for the protein is nitrogen, students. So that's why it is very important element for the plant life. So properties of nitrogen, it's a colorless gas. Properties of nitrogen means not the element nitrogen gas N2 only. Here many students have confusion between N and N2. N is only element, N2 is a molecule of element which is available in the nature. N or N2, N2. So we are talking about N2, nitrogen gas. So it's a colorless gas, tasteless and odorless, right? No color, no taste, no smell. It is slightly lighter than air and is very slightly soluble in water. Very slightly, almost insoluble in water, we can say. Very slightly. So it is neither combustible nor a supporter of combustion, right? Is it undergoing combustion? What is combustion? Burning reaction, students. Like a match, lit a matchstick in the air. Almost 78% is nitrogen only. Like, is it getting ignited? Is it getting burning? No. So it's not a combustible substance and it is not a supporter of combustion also. What's the meaning of supporter of combustion? So the burning doesn't take place only in the presence of nitrogen. That's the meaning, right? So it does not easily react with other chemicals also. That's why mostly nitrogen gas is called as inert. It's not an inert gas. Inert gases are noble gases, right? Helium, neon, argon, krypton, xenon. But nitrogen is inert towards the chemicals. Why? Because nitrogen bonded with a triple bond with another nitrogen. One of the strongest, three bonds are there. So mostly it is inert. That doesn't mean it is unreactive. It is reactive. When we make that condition, when we make that temperature pressure condition, it will react. So we have the chemical reactions also, right? In general, it is inert towards the chemicals. So significance of nitrogen in the atmosphere. What is the importance of nitrogen? It dilutes the activity of oxygen. Thus, the combustion of fuel during the burning takes place at a moderate rate. Students, for example, lit a candle and at the normal conditions, you can see a flame, right? Okay, notice that. And if you do that, the same lighting a candle only in the presence of oxygen. You already know in the air 21% is oxygen. If it is 100% oxygen, do you think the level of the flame, the height of the flame, is it the same? The answer is no. The height of the flame will be more. The candle burns more vigorously if it is 100% oxygen. Understood? Why? Because combustion reactions takes place in the presence of oxygen. More is the oxygen, more is the rate of combustion. Presence of more nitrogen, now the combustion becomes moderate or not? Sir, if it is moderate, it is not good for, it is good. Like if it is more energy, but it is okay. But if it is more rate of combustion happens in the air, students, in the normal atmosphere, what happens? Think about forest fires, think about all the explosions, volcanoes, what will happen? Destruction will happen, right? That rate of combustion will be controlled by this presence of nitrogen or not? That way it is helping the combustion rate by reducing it. So, right, the compounds of nitrogen are of vital importance to the plants as they help to plants to manufacture the proteins. Like I said, proteins, one of the key element is nitrogen. However, free nitrogen cannot be absorbed by the plants. The free nitrogen is converted into its compounds by the following natural methods. So, nitrogen is there in the air, N2. So, like, is that nitrogen directly gets absorbed by the plants? Absolutely no. Students, of course, there are some type of plants where it happens, but in general, we are talking about in general. Then how do the plants get the nitrogen? In the soil, the nitrogen is there, very, very minute. Okay, very, very minute, mostly present in the air only. Then how do plants need nitrogen? Yes or no? We are using all the fertilizers, right, students? What are the fertilizers? Ammonia. What is the formula? NH3. Urea. What is the formula? NH2CO, NH2. All they contain nitrogen. Yes or no? So then how do plants get this nitrogen in general? We are not by artificial, in general, by this set of reactions. So students, nitrogen is there, oxygen is there. I said clearly, nitrogen is not completely unreactive, it is reactive only. If you can maintain that condition, sometimes by the nature also. So this process is a magical process, explains the beauty of the nature. Students, see, nitrogen gas, oxygen is also present, right? Oxygen gas, are they reacting in the air? No. But during the thunderstorms, during the lightning, an electric spark passes through the air. Due to this spark, nitrogen combines with oxygen to form nitric oxide. You already know chemical reactions takes place at a certain conditions, right? Conditions like temperature conditions and pressure conditions. Yes or no, students? So because of these temperature conditions, the bondings will be broken, the new bonds will be synthesized. Yes or no? That is what a chemical reaction. So nitrogen gas combines with oxygen gas and it forms nitric oxide, which is 2NO. Nitric oxide. That doesn't end here. So we have a process. This nitric oxide, students, reacts with excess of oxygen, it forms nitrogen dioxide, and this nitrogen dioxide in the presence of moisture, which is oxygen and water, it forms nitric acid. All this happens in the air only. All this happens in the air, and when these nitric acid droplets, when the air condenses like to form about to rain, so this acid, nitric acid molecules mixed with the water droplets and it falls as acid rain. Understood how it is happening? Now this nitric acid, when it reaches the ground contains many minerals, right? Like land, the soil contains many minerals. So mostly it contains calciums, magnesiums, carbonates, bicarbonates. Now this nitric acid which falls on the ground reacts with carbonates of calcium or magnesium and it produces the respective calcium nitrate, students. Calcium nitrate and carbon dioxide and H2. These two are least considerable. So this is the main chemical what we are talking about, the whole thing. This acts like a fertilizer for the plants. What is that? Calcium nitrate. Sometimes not every time it's a calcium, it can be magnesium also. What is calcium? Where it is present? CaCO3 means limestone. Yes sir, no, students, right? That's what it is. So that's how look at here, from the nitrogen it is converting into nitric oxide and that becomes nitrogen dioxide, that reacts with water and produces nitric acid. It falls down, reacts with the calcium carbonate in the soil and produces calcium nitrate, which can be consumed, which can be absorbed by the plants. So ultimately nitrogen is reaching to the plants or not? This is the process, right? So next, students, symbiotic bacteria. Symbiotic bacteria means a bacteria which is in relation with the plants, like both in both ways, helping in both ways. So are present in the nodules of pod bearing plants. Pod bearing plants means chickpeas, like in general peas, grams, sweet peas, etc. The bacteria absorb nitrogen directly from the air and convert into the compounds of nitrogen. So like I said, there are not all happens by the same process. Some type of plants have this mechanism also where they can absorb nitrogen directly from the air by using this bacteria. So these compounds are absorbed by the plants for the manufacture of proteins. Ultimately, what is the main purpose? Proteins. So nitrogen being the inert gas, students, here many students will confuse. Inert gas means many students are, will think like the inert gases in the periodic table, 18th group elements. This is not inert gas. Inert gas meaning not the family name. Inert gas meaning mostly it is unreactive. Mostly nitrogen gas is unreactive. Is it completely unreactive? No. We have seen some reactions in the previous slides, yes, sir, students, right? So inert gas is used in the preservation of foods also, right? For example, Lay's packet, it is full of gas, right? What it is present? Do you think oxygen is present? No, if it is oxygen, the chips will be spoiled. Why? Because the bacterial growth takes place in the presence of air. Air contains oxygen. So all the air was removed, only nitrogen was kept. It is an inactive, yes or no? Bacterial growth, fungus growth was not expected under this gas. So it is even used for the preservation of foods also. Next, these containers containing food are flushed with the nitrogen to drive out the oxygen and then sealed. Because of the absence of oxygen, the bacteria do not grow and hence the food remains fresh. So that's what we can see in our daily life. Yes, sir, students, all the packaging food mostly contains air. That air is nitrogen only, that gas is nitrogen only, not complete air. So uses of nitrogen. Nitrogen gas is nowadays being extensively used in the food packaging, just now we discussed, to keep the food fresh. For example, packets containing various snacks such as potato chips, pre-cooked and pre-wasted ready to eat food items have nitrogen gas filled inside them. All the kind of pre-cooked, that means ready to eat food, so mostly packed with in the presence of nitrogen gas only. As being inert in nature, nowadays it is filled in the electric bulbs also along with argon gas to provide more life. Even the bulbs also contain some gas, as certain students, and that gas should be unreactive. Why? Because it's a spark, glowing light. At that condition, mostly the gas should be unreactive. There also, along with argon, nitrogen is also being used. Why? Because nitrogen is mostly unreactive. It is reactive, but mostly in general it is unreactive. So liquid nitrogen is used during the skin grafting in burn victims and in vitro fertilization, that means test tube babies. So skin grafting means, students, changing the skin from one area to the another area. Sir, no. So how this liquid nitrogen is used? Why? Because it is one of the coldest substance, liquid nitrogen. So to avoid spoiling of that particular material, they use liquid nitrogen. And as well as test tube babies also. Yes or no? That is not possible in the normal conditions. That should be possible only in a certain sophisticated conditions. Yes or no? There liquid nitrogen is used. What is the main purpose of liquid nitrogen? It avoids spoiling. That means rancidity doesn't happen. Decomposition will be stopped. Not completely. There is some time where we can do whatever we want to do in that time. So we use liquid nitrogen. Even heart transplants are there, students. Body organs transplantation. So how do they transfer? By keeping them under liquid nitrogen only. Why? Because at that cold temp conditions, the spoiling of that particular organ will be stopped. Got the clarity? So liquid nitrogen is used as a refrigerant for freezing food, even for the food items also. Nitrogen is used in the production of nitric acid, one of the key chemical used in the many organic reactions also. And ammonia, what is the formula of ammonia? NH3, which is used as a fertilizer. Ammonia is used for manufacturing of fertilizers and explosives. From ammonia we can synthesize many fertilizers as well as explosives also. The nitrates are mostly explosive, students. Potassium nitrates, sodium nitrates also. So that's it about nitrogen gas. Next, carbon dioxide. What is the formula of carbon dioxide, students? CO2 is carbon dioxide. Now answer, students, carbon dioxide, CO2, is it good or bad? Of course, to the nature, everything all are same, all are equal. For us, it is good or bad. So the first point that you will get in your mind is, sir, CO2 is very bad, but CO2 is very, very good to our planet Earth, students. How much is the percentage of CO2? The percentage of carbon dioxide in the air by volume varies from 0.03% to the 0.04%. The areas where a lot of fuel burns have more percentage of CO2. Yes, sir, more burning industrial areas have more percentage of CO2. In photosynthesis, the process carbon dioxide plays an important role. CO2 gas is released during the respiration process. Yes, sir, now CO2 is one of the main chemical for the photosynthesis reaction. I am not saying because of that reason it is very, very important, students. The main reason is, students, the main reason is our earth contains atmosphere, sir, no, mixture of many gases, right? So our earth is revolving around the sun as well as on its own axis also. So one part of the planet earth is exposed towards the sun, other part is opposite to the sun. Yes or no? Opposite to the sun is night, exposed towards the sun is the daytime, right? That's very simple thing. Now listen carefully. Opposite side, students, when it is not exposed towards the direct sun, opposites during the night time, in general, if there is no CO2, the earth would become icy part. It might become a icy cold climate at the night times. But is it happening? Night times, is it becoming very icy cold climate? No, because of CO2. Because of the presence of this less percentage of CO2, CO2 has one nature, student, that is called as it can traps the heat energy. Because of this heat energy, the temperature levels were not dropped completely, significantly. It maintains the ideal temperature even at the nights also. If you can check the remaining planets, at daytime they are very hot, like which are very closer to the conditions of their sun, their stars. And at the opposite side, they become icy cold. But why it is not happening here? We have the perfect percentage of CO2. But what is the problem with CO2? If CO2 increases, like for the same reason where it traps the heat energy, the temperature will be raised. Yes or no? By more is the CO2, more is the trapping heat energy. If the temperature gets increased, then the polar regions, polar ice caps will melt. If they melt, that increases the sea level. Yes sir, that is called as global warming. The globe becomes warm. So that's the problem by increasing the levels of CO2. But whatever the percentage of CO2, that is good for our planet Earth only. So remaining points, the reactions, everything we'll discuss. So that's all about CO2, students, introduction. So significance of carbon dioxide in the atmosphere is the same, like I said, importance. It acts as food for the plants, right? All the food synthesize carbohydrates from what reaction? CO2 plus H2 reaction. Yes or no? Photosynthesis. So during photosynthesis, plants absorb carbon dioxide and water vapor. These are converted into carbohydrates and oxygen in the presence of chlorophyll. Chlorophyll acts like a catalyst, a green pigment, and sunlight. 6 CO2 plus 6 H2 gives rise to C6H12O6. This glucose and oxygen gas is also released, that maintains the cycle of oxygen and CO2 in the air. So right, this is very, very important point. And carbon dioxide dissolved in water can dissolve rocks containing calcium carbonate and like in general called as chalk, and magnesium carbonates. These salts so formed and become calcium bicarbonates and magnesium bicarbonates, and these dissolved salts gives the taste to the natural water. Water is tasteless only, but for the normal water, drinking water, it has some like good taste, drinkable taste. Yes or no? We can't explain that taste. That is because of the presence of these minerals. Mostly contains carbonates and bicarbonates of calcium ions and magnesium ions. So further, they satisfy the needs of the plants for the growth by providing these ions. Calcium and magnesium ions are needed by the plants. Why? Because they require nutrients. Yes or no? What are nutrients? Minerals only. So look at this reaction. How do we get this natural taste to the water? So calcium carbonate in presence of water and CO2 produces, this is calcium bicarbonate, and the same thing happens in the case of magnesium carbonate. Will get magnesium bicarbonate, that gives the natural taste to the water as well as that provides nutrients for the plants also. Here what compound we are talking about? CO2. So preparation techniques. How can we synthesize CO2? It's a very simple task, by burning. Yes or no? Combustion reactions, burning wood, burning petrochemicals, diesel, kerosene, LPG, all by burning. What is the gas which is getting released? Carbon dioxide, CO2. So by combustion, carbon dioxide is formed when carbon in any form or hydrocarbon is burnt in excess of air. C plus H2O, C plus O2 gives rise to CO2 here. Students wrong. C plus, students, O2 gives rise to CO2. Simple reaction, students. By burning any hydrocarbon, what do we get? Carbon dioxide. And this is the general reaction with methane. CH4 plus 2O2 gives rise to CO2 plus 2H2. If it is a methane here, if it is ethane, or if it is propane, butane, pentane, hexane, any hydrocarbon, what is the common gas gets released? CO2. That's why increasing CO2 increases the global warming. Yes or no? So what we have to stop? Burning the fossil fuels. What are fossil fuels? Petrochemicals. So by heating metal carbonates also we can synthesize CO2, students. Metal carbonates, what is the group it contains? Carbonate, CO3 minus 2. Look at the reactions. CaCO3, calcium carbonate. It produces calcium oxide plus carbon dioxide gas. And bicarbonates also, NaHCO3. Sodium bicarbonate produces sodium carbonate as well as carbon dioxide gas is released. So here one of the component which is produced is CO2, which the discussion is about. So next, by the action of acids with carbonates. So this reaction also, when acids react with carbonates or bicarbonates, the common gas which is released is CO2. Why? Because it has a carbonate group, CO3 minus. Look at the reaction, CaCO3 plus 2HCl gives rise to CaCl2 plus CO2 plus H2O. CO2 gets released. Remember, the acids plus carbonates, definitely CO2. Acids plus bicarbonate, definitely CO2. And the salt depends upon the type of chemicals which are reacting in this reaction, which are participating in this reaction, right? So next, uses of carbon dioxide. So what are the uses? Does it have any uses? Many uses are there. So carbon dioxide does not support combustion. Yes or no? Does it support combustion? No. Then what happens in like opposite? It stops the combustion, right? It is used as a fire extinguisher. So the carbon dioxide therefore used for extinguishing the fire, that means to put off the fire. Like how does it take place? In the coming slides I'll explain. So carbon dioxide solidifies on cooling to around how much? Minus 79 degrees Celsius at the atmospheric pressure. Solid carbon dioxide is called as dry ice. Students, if you order ice cream from some company brands, you'll get some ice cube kind of thing, right? What it is made up of? Dry ice only. That is not H2O normal ice. That is solid carbon dioxide. It suddenly vaporizes. Yes or no? You can see the white fumes coming out of it. So that is dry ice, mainly used for this cooling purpose. So to maintain their cooling purpose. So right, carbon dioxide is used in the preparation of aerated drinks also. Aerated means carbonated drinks. For example, normal soft drinks, thumbs up, Coke. Yes or no? So what is the use? What is the use? I will explain. Listen. Have you tasted this carbonated drinks, soft drinks, without cooling? Without cooling, like after all the gas was gone. Have you tasted? How does it taste like? It tastes like a sugar water. Yes or no? Now the fresh soft drink, when you open it, what is the sound you will hear? Shh kind of sound. Yes or no? Why? Because it is completely pressurized with CO2. It is completely CO2 gets dissolved in that. So that CO2, students, when the liquid which contains CO2 touches to our tongue, it gives a chilling effect. The CO2 molecule simply plays in our tongue. So that gives a chilling effect. For that effect only, this CO2 is used in the carbonated drinks, which are also called as aerated drinks. So liquid carbon dioxide is used in the sugar industry, students, as well as in the destruction of insects also. The mixture of 95% of oxygen O2 and 5% of carbon dioxide is called as carbogen. Very, very important point, students. This mixture is called as carbogen. Where it is used? It is used in the medical industry for artificial respiration, breathing purpose, mainly for the patients of pneumonia, like it's a kind of lung disease. So there it is used. The carbon dioxide is used in the process of photosynthesis by the plants, that we already know. We have already been discussed about that point. So last, fire extinguishing. What is fire extinguishing? In your school, if you have seen, there are red cylinders everywhere. Sir, no, what is that? What it is made up of? What it contains? That contains carbon dioxide. Why that? Why? Because if any fire accidents happens, we need to stop that fire. Sir, no. How? Throwing water. Not every time. So carbon dioxide is the best fire extinguisher. That means it forms a foam kind of substance on the fire. So that completely cuts the contact of oxygen. Why it is burning? Everything. What I said? Because of oxygen supports combustion. So when this foam kind of CO2, when it spreads on the fire, the contact of the fire with CO2 will be gone. Yes or no? That put out the fire. So CO2 is the best. So water, for an electric switch, some fire shock happened. Do you throw water? What will happen? Gone. Yes or no? So CO2 is the best. Oil, you throw water, no, oil settles, stop. Yes sir, it's keep on burning. So see, that's why CO2 is the best fire extinguisher. So directly CO2, sometimes these fire extinguishing techniques have some chemicals inside. When these chemicals were mixed, they release CO2 also. That's what the paragraph is about. The fire extinguisher contains concentrated solution of sodium bicarbonate. What is the formula, students? NaH, sodium bicarbonate, NaHCO3, and a bottle containing concentrated sulfuric acid. What is the formula? H2SO4. So when the apparatus is turned upside down, the acid flows out to the bottle and produces carbon dioxide by the reaction with sodium bicarbonate. That means NaHCO3 plus H2SO4. You imagine, you guess the products. We'll get, what is the salt? Sodium sulfate. What is the gas released? Here we have carbonate. What is the gas? Carbon dioxide, and H2O is also released. So this reaction is used to stop the fire, to put off the fire. Ultimately, for what purpose? For the release of carbon dioxide only. Carbon dioxide is the best fire extinguisher. So that's it, student. These are the like significance, importance, physical properties and the chemical reactions of nitrogen and carbon dioxide. So still we have impurities, water vapor, that we'll discuss in the next video. Thank you, students.